Let's start with the first speaker. 15 minutes. 15 minutes?
15, more or less, yeah. So, good afternoon. First, let me make a brief comment on the title of my presentation, which is the follow-up of another presentation that took place last year in Cairo for the ASREN 2018-17 meeting, E-Age meeting, where I presented a tool, a technological tool, namely the first ontological platform on cybersecurity, which means not only knowledge representation, but also services to cybersecurity. Today, I would like to talk about that to explain why in the field of R&D and also of company market, this item is very important. Let me simply say that you won't be here, you possibly won't be here in the future unless networks are protected and devices are protected as well. This is a matter of cybersecurity, which is the counterpart of the digital transformation revolution. I shall try to go fast because time is not enough. Doesn't work? Why? What happens? Bravo. Can you give me the presentation? Yeah. No? Bravo. Okay. Let me start with an obvious consideration, the increase of cyber attacks. And since we talk about internet, say, infrastructures as far as education and research is concerned, I tell you that among other domains, last year, first semester, was a growth of 138% of attacks in the domain of online research and education. I should comment on what I mean by cybersecurity as a service, but let me simply say at the very end of my presentation, this is my proposal to anybody who might be interested, is the development, the further development of our platform, which is already excellent and working. It is technology, it is not a project, to become an integrated framework for cybersecurity defense. Of course, in the world of activities in this field, everybody is looking for the definition of standards and tools for prevention, detection, and resiliation in cyber attacks. I shan't say anything about the approach. Let me only say that if you take a look at cybersecurity market size, the estimate is that this market size will grow up to $170 billion by 2020, and have to do with the number of stakeholders, which is the one that you see mentioned. I go quickly. And as for sub-markets, of course, different types of security types: network security, endpoint security, application security, content security, wireless security, cloud security, and of course a number of activities, as you see by service. As you know, the most dangerous activities concern governments. They talk about cybersecurity and cyber warfare, and this is very, very, let's say, only problematic. Of course, public utilities. In the European Union this year in May, we have definitely accepted two laws, two norms. They have to do with cybersecurity and protection, data protection, and they imply a very strong compliance by vendors and by institutions and companies as far as security is concerned. So they must be compliant. They must do risk assessment and risk evaluation. And there are no automatic tools so far that allow for these activities. This is an infographic where, for the first time in ESA, which is the European Agency in Cybersecurity, utilizes a very important thing that is called kill chain. And namely, if you want to understand what an attack is, you must have the path of the attack. And so far, many analysts move only on a local analysis, which doesn't say much, and it is not much useful for elaborating defense. As for the typology of logical impact, it has to do with enormous amount of money that could be lost by companies and institutions. Of course, if we leave aside espionage, even though, industrial espionage and let aside political institutional espionage, of course, data exfiltration, destruction, manipulation, service, data encryption, these are some of the typologies of logical impact that could create big problems. Things of of the financial infrastructures, of banks, of energy, of water, of transport. These are the implications. So, I won't say what I mean by cybersecurity by defense. I shall always say that if we want to face this kind of challenge, we must have 3 blocks of activities. And the most important one, in my opinion, is to understand the phenomenon. And we can do that by knowledge, representation, and info sharing. This should give us the solutions for detection, removal, and alarm of cyber attacks, and get into prevention and prediction. Companies that sell cybersecurity solutions say that they allow you to do prediction, prevention. It's ridiculous. No, there is no such technology so far. So let me come to the most interesting part, in my opinion, of what I wanted to tell you, that has to do with the tools, which means scientific tools for knowledge representation, which has to do with the notion of ontologies and taxonomies. Nowadays, tools and standards for the evaluation of taxonomies are in a sort of what I call a Babel status. I want just to mention a statement by Guarini at the very end of last century, where he explained the relevance of ontology in the fields of artificial intelligence, computational linguistics, database theory, and he explained that it is a very highly interdisciplinary field. What I was saying to someone before coming here is that you cannot have a data architecture, or even you cannot have an ontology, a taxonomy, unless you know what you're talking about. So data semantics have nothing to do with the courses that are at present studied at universities in the field of computer science and engineering. So we have to have different means of facing this kind of research domain. This is more or less when I have to make a representation of artificial intelligence proposed. A digital mind, namely artificial intelligence, is not the sum of different applications, for instance, in the field of machine learning, deep learning, etc., IoT. It's the emulation of the function of human brains as far as data are concerned. Therefore, artificial intelligence and data are related, strictly related, because we need modeling of data by means of the definition of logical semantic relationships. Here I would make a brief explanation. This morning I understood that I didn't get in technical contact with an intervention of mine with the person who was speaking. Metadata languages are not up to the point. They are solutions for technological interoperability. We do not have so far tools for having logical semantic interoperability. This is the point. And so far, logical descriptors cannot take so far into consideration this dimension. So if we want to have a knowledge representation, we must have a logical semantic representation of contents. As this is the kind of approach everybody should use. I mean, a middle-out approach means that we have used data coming from different sources, but we have restructured data and reformulated data. Let me come to the distinction between ontologies and taxonomies. In many cases, I mean, the two things seem to go together. An ontology is a system of entities related by logical, semantic relationships, which are not the ones you're used to face in most literature. You have the definition is a, and then you have properties and attributes. This is too little. You'll see how the application can go a little bit further. Taxonomies instead should be classifications. The classifications of data, as you shall see in the experiences I shall present, are really very poor. The question is why? Why classifications are so poorly done? So what I shall briefly sum up for you is literature on the subject that can be articulated into general versus domain and subdomain ontologies, ontologies and taxonomies relations, vocabulary standards and goals of description. You will notice briefly these four contributions, among which I put mine as well, of our ontology platform, are midway between a general upper-level ontology and domain ontology. This complicates things because if upper-level ontology is not well-defined, you cannot have a good domain ontology. You will also notice briefly how ontologies change their entitling. We talk now about cyber threat intelligence and resilience, semantic threat modeling, cyber threat intelligence, vulnerability ontology. Wow, wow, wow. These are all components of a general ontology. And as far as taxonomies, this is a very good one. Barhead and attack taxonomy is quite good, whereas ENISA was a disaster. This is the result of ENISA work where they compare some 30 certs having to do with classification of malware, and they say they didn't even succeed to have an upper level categorization. So it's terrible. Now these teams Celsius must work together, and they don't have a basis to work on. And this is the most interesting proposition by NIST. NIST has done a fantastic amount of work in this field with the Metric Corporation. They spent a fantastic amount of money, and this is their proposal, where they propose the ontological development of platforms through control vocabularies and semantic interoperability. You can see on the right and left down, they give an example of what, say, the types of relations should be. This is only partial. This is the beginning of a more complicated work. This is what they have done. If you visit internet through these links, you find out they have done a fantastic amount of enumerations of concepts. And this is the way they have taken care of bugs, vulnerabilities. They have a fantastic open database where you can see day by day, I would say week after week, what type of incidents they have taken care of, and it is open to any form of collaboration. This is an interesting resilience ontology put forward by ENISA 2011. If I can show a flaw, the flaw has to do with at the taxonomical level it might even be accepted, but there is no ontological model behind this ontology, which is also very interesting. This is the way they represented business ontology. And so I need 5 more minutes. This is a Norwegian project. Well, of course, the same is true for this proposal. This is not an ontology. It's very nice articulation items. And this is a comparison of ontologies where 60% are concentrated on attacks. But as the authors state, there is no possibility of verifying the quality of the analysis. This is what they propose, and this is, so far, is not, at best, it might be a taxonomy. It's an interesting listing of items. I want to stress, I shall come in a minute to conclusions. If you have a look at people who pretend to apply metadata languages to ontology, making a mistake, the mistake is quite visible here. These kind of logical descriptors have nothing to do with the description of logical semantic relationships in a knowledge representation. Excellent, as I say, excellent synthesis, but no useful for the purpose. This is one of the proposals. Anyway, when they come to the point of listing what they call important classes in ontology, they simply list a number of items, important items, but no ontology. Means, consequences, attack, attacker, attack pattern, exploit, blah, blah, blah. The only useful proposal is that have a network, what they propose, a linked open data, where a number of sources for ontological development are available. Limitations of this approach I have already said. This is another comparison. Let me come briefly, and so I will get to the conclusion of what we have done. We have proposed univocal applications of representation concepts, namely entities and their relationships, both at the upper level and the mid-level ontology. The constituents of our platform, which is operative, it is not a project that has to be done. It is done. It is a prototype, and we propose it for collaboration in this context. It has to do with cybersecurity domain ontology as a general domain ontology, a cybersecurity pragmatic ontology, which has to do with applications, with cybersecurity knowledge and semantic vocabulary in general. So we deal with different levels, entities, semantic and pragmatic relations. More or less, this is the structure where we have avoided the mistakes of classifications and ontologies. They have to face equivocal definitions. Natural languages are equivocal, polysemic by definition. So this is the point to be explored. And so I was structured both taxonomical and ontological. This is more like it looks, our ontology. And anyway, I have come to the end. We propose in our platform, this is a screenshot of the platform, which is online, of course, 7 analytical areas for specific cybersecurity services, and in particular, a tool area besides the ones I mentioned before for risk assessment, risk evaluation, remediation techniques, specific applications for data recording and incident reporting, statistics, metrics, and so on. What are my conclusions? I think that from this, first of all, I want to propose a joint venture with people who might be interested in this kind of activity. Just think of all over the world, big companies try to work on the supply of solutions. What I wanted to say that my proposal for enhanced context is an integrated platform having at its core proposal cybersecurity as a service, where on one side we have to do with description, knowledge description, and on the other side with design tools that can be used both by the research community and by vendors, developers. They need to know what to do, so a platform, integrated platform, could be helpful in this perspective. That's all. Thanks for the attention.
Thank you, Elisa. And now with our second esteemed speaker, Salim, the floor, Al-Ashhab. Not Abu Shanab or Al-Shanab.
The correct name is, this is the correct name appearing now, and this is the name of the university, abbreviated as AAPU. Okay, now I am a mathematician, as I said yesterday. I want to talk about magic squares, so it seems to be mathematics with some mysterious things, yeah? But it's, maybe some people think that this is a mysterious subject, but I talk about mathematics now. So this is slideshow? Oh, right. Yeah, what is a magic square? So by a magic square, we mean a matrix where the sum of integers in all rows, columns, and both main diagonals is the same. This is called the magic constant. I will give you now an example, non-example from the ancient times, Chinese times. So if we sum in the first row or any other row or column on both main diagonals, like 2, 5, 8, so we get 15, or 4, 5, 6, we get also 15. And actually, this is the only square up to isomorphism, as we say in mathematics. So you can rotate, you can reflect, and you get the same square. So just one square. And now I can define a general magic square of order n, so that I will arrange the numbers from 1 to n square in an n by n square or matrix. Of course, all enters distinct, and I want to have the same sum in all directions. So I have, according to mathematics, to take the magic constant n by n square plus 1 over 2. For example, now the magic square of order 6 will have the magic constant 1, 1, 1. As I told you, there's only just one square of order 3, well known from ancient times. Of order 4, it was known 200 years ago. It was 220 times 32, and now 32 stands for the transformations, which take one square to others, but actually it's the same square in the ascension. So this result was at the beginning of the 20th century, verified by computers. At the beginning of the 20th century, it was verified computationally by mathematicians. Of course, it was verified by computers as the result of the 5 by 5 squares. It's a big number, about 2 billion. This was computed in 1973 using computers. Okay, it took 2 days in that time to calculate this number. Now, the challenge is to calculate the number in case of order 6. This is an open problem where I work. Yeah. 10 years ago, I found this link where you find the code, and they said it will take about 220,000 years to calculate the number of all natural squares of order 6. And there are some people, non-mathematicians sometimes, they have estimated the number to be about 1.7 times 10 power 19. So this is still an open problem where I work. Now I defined some special cases, subsets, we say in mathematics, of the magic square in order to be able to calculate it. So now, pan-diagonal magic square, we add some properties like all pan-diagonals sum up to the same magic sum. And the four-corner property magic square, the sum of all corners of any inside 4 by 4 square sums up to 74. As we use in mathematics the symbols A11 to A66 to denote a matrix, so I have 3 equations, and the 3 equations should lead to 2s, where 3s is the magic constant. Okay, 3s, now 2s is 2/3 of it. There are a lot of such squares. This is one of these squares. I have finished counting these squares 3 years ago, using an HPC access to the grid system offered by the European Union in that time from Italy. So thanks. I would like to thank them for that help. Now this squares, for example, if you look at the corner 13, 3, 23, 35, it will sum up to 74. Also, the middle squares, 27, 10, 22, 15, sums up also to 74. So, how is the program constructed, and why do I need HPC, and how can we make some codes? This may be interesting for other people not understanding very well mathematics. So I have loops, nested loops sometimes, where and I have at some stages some variables to be calculated, and these variables must satisfy the conditions right down below here in order to be in the range from 1 to 36. So nested loops will make it easy to make parallel computing. Okay, so if you use parallel computing like the grid system, then you can split the job into so many jobs. them done simultaneously, and then you get all the results and collect them together. So the program, as I said, some of which it's easily parallelizable. It can be split into several problems, and our task as mathematicians is to use symmetries in order to reduce the runtime. As I said, there are sometimes 8 transformations, sometimes 32 in the case of 4x4 squares. So mathematicians think, how can we make transformations, property preserved transformations, that will reduce the amount of calculations. And the task will be then carried out by computers when we have the right code for that. In the case of 6x6 squares, I was able to find 16 property preserving transformations. So the number which I will get is going to be multiplied with 16. So actually, I said it's very hard to calculate all 6x6 squares, so I have made a subset. Here I took the main diagonals and have put some conditions on the diagonals in order to avoid symmetries, to do calculations. So each unique pair of diagonals, okay, presents a different general pair of diagonals. These are the conditions, something like arrangement of the numbers. This can be done by some permutations, some rotations. And this is the number of all 6x6 NPDs. It's a huge number, and every 2 pairs of diagonals will represent some squares. We have to use them. Then I have moved one step more in order to be able to calculate something without HPC, using my own computer, because I don't have access to HPC, and that's why I was coming here in order to search for access to HPC in order to carry out the job. Now I've considered 2 subsets where I put some conditions on the main diagonals for the K's or the L's, that is, they sum up to 37, which is 1/3 of 111, okay? Which is now 1S. So they are called the first subset centrally symmetric pairs, where we think that's symmetry about the center, and the one with these 2 conditions just for K and L, it's called axially symmetric. And I have got these main results. Now, the number in the middle line, in the middle of the page, where we find the number of balanced magic squares, which is the title of my presentation, but with the square matrix with self-similar pairs of diagonals. It's this huge number multiplied with 24 and 8. And as I said, these factors corresponds to some transformations. So 8 is the non-classical 8 transformations of a magic square. 24 is another one, just specifically for this type, where we use the property of being self-similar pair. So this will give you more transformations, property preserving transformations. They would reduce the runtime, and you can get the actual number by multiplication with these 2 factors. I have also calculated so many other subsets. Just numbers, for me, they are important. For some others, it's not very important. But I think that this is a joint point where IT experts can cooperate with mathematicians in order to solve some of their problems, and to test their computers, to test their codes. Okay, they can get some ideas out about some problems from the mathematics which are unsolved till now. At the end, I can say in this paper we walked further steps in the direction of solving problems of counting magic squares 6x6, the subset of 4 corner magic squares was counted in 2. It's a reference written by me. I will show it later. The number of free types, free variables, or the independent variables, or the loops, let's say in the language of IT, the loops were 18. Well, the number of these loops will be 21 for the case of balanced squares, and 23 in the general case. And when we have more loops, then we have more calculations. And so that's why we need runtime or use HPC in order to be able to calculate this. So in the future, I hope that I will be able to calculate at least the number of balanced squares using HPC or some high performance computers maybe available in our country, Jordan. At the end, as I said, here are some references where I talked about some results and also some people from all over the world, like Trump in Germany and Bruno, who are talking about magic squares. We are a small community of mathematicians and non-mathematicians interested in such problems, and here's a list of my work on this topic, magic squares, which I finished actually in 2016. I'm taking a rest because I don't have access to HPC as I had before. And thanks for listening.
Many thanks, Salim. It's now with our third esteemed speaker, Mahmoud. Please. Thank you.
Assalamu alaikum. Good morning, good afternoon. My name is Mahmoud Muhammad from Simad University of Somalia. Today I want to share with you evaluation of ICT in Somalia higher education, the weakness and strengths which are existing there. And these 2 days we have been talking about the importance of ICT in education, especially in higher education. And yes, there is importance in the utilization of ICT. But in some countries, higher education is really using ICT as required, while some other countries are still behind. In my country, most of universities started to use even computers in 2000. This means they are in the early stage. At some time, according to my knowledge, there's no researches in the area of ICT in the utilization of higher education. The objective of this research is to know really the status of the ICT utilization in Somali higher education. How far society know about the importance of the utilization of ICT and the real status of the utilization of ICT in our higher education. We selected 30 universities in all over country and distributed 300 copies questionnaire. This is our proposed model to know the real status of the ICT in Somali higher education. We selected 4 categories, and each category has some indicators. For example, ICT infrastructure, to know the real status, we used 5 indicators. And each of these 5 indicators has his own sub-indicators. ICT strategy plan we used 4 indicators. Institutional ICT learning, we used 3, and society attitude towards ICT, we used 2 indicators. Those are 14 indicators, and the result will be based on these 14 indicators. The findings showed ICT infrastructure, and really we were looking at this stage, and this stage is between 1, ICT stage, and what I mean, between 1 and 4. 1 is the lowest stage, and the 4 is the highest stage. As you see here, minimum indication is 1, while the maximum is 2.9. So access to the RBC or shared computer 2.9, network speed 2.6, those are above average. But internet availability is low, it's 1. In the side of institutional ICT learning, and the lowest indication shows availability of adequate local content. Those universities are missing local content. 0.6 is less than minimum stage, but all less than average, 1.5, 1.4, it shows weak. ICT strategic plan. Measuring on this, the weakest area here is ICT security. It's very weak, 0.8, less than 1. The other are average. Society attitude. For the society attitude, there were 2 indicators. Management awareness of the ICT importance and the staff understanding of ICT benefits. Those are sub-indications. And normally, this area, the only problem is showed is management attendance, attention to the ICT important. But mostly is above average. Overall performance of the 14 indicators are shown here. 3 indicators are very low. ICT security, internet availability, and availability of adequate local content. These 3 areas is very weak. The others are, yes, some less than average and some above average. In conclusion, the stage of ICT utilization in Somalia higher education is 46%, lower than average. Lower than average. The area which is very weak, as I said before, is the local content, ICT security, and internet availability. For example, for internet availability, 1 MB is around $300. So it's not easy to use internet in anywhere, in the campus or out of the campus. This was my recommendation to the government and to my universities, Somali universities. These 3 items are to be solved urgently. It's the local content problem, ICT security problem, and internet affordability problem. What I know is all of you are familiar with this problem. So I appreciate if you contribute, how can we solve this problem? Thank you.
Many thanks, Mahmoud. And now is our fourth speaker, Abid, please.
Assalamu alaikum to everyone. I will be presenting tactical data link, resilient long haul, wide medium for tactical armed forces communication networks. My name is Abid Ali Minhas. I am from Al-Yamama University, Riyadh, Saudi Arabia. This is actually joint work, and we are actually three authors: Ahmed Qaddous, me, Abid Ali Minhas, Hamad Anwar Sayyed. This work is actually done in Pakistan for Pakistan Army. In Pakistan, there is a National Radio Telecom Corporation, city Haripur, Pakistan, and then Bahriya University, Islamabad, Pakistan, and the third one is Al-Yamama University. Flow of presentation is that first abstract, then study of existing system, motivation of the problem which was identified, then in a statement it will be described, and what were the research objectives in order to solve this problem, what were the design requirements that we put for this, and then we proposed a solution, actually more than one. I'll explain you. Then we fixed some design parameters, functional parameters, and at the end I will discuss the results that we achieved, whether they were going to meet our design requirements or not. Finally, conclusions that will be presented. Now, the first thing is abstract. In this research, problem of communication link that is solved, and we have proposed the use of three deployment scenarios for the achievement of maximum data rates through the tactical data link system over 15 kilometer hop length. The first was deployment of a thick copper conductor diameter wire, AWG15. It was modified to another one, AWG18, which offers actually low resistance, which further allows maximum flow of electrical pulses through it, and this results in low bit error rates and high signal to noise ratio. Then we proposed third solution. I will explain you why we proposed three. Deployment of a TT wire channel. It is proposed to adjust the transmission and reception line rates of the technical data link system units, both on the transmission as well as on the reception sides. We did some changes in the firmware setting, then configuration, which can allow the technical data link system units to transmit and receive even in poor conditions with thinner copper conductor diameter wires. First I will tell you what was the existing system present with Pakistan Army. The technical data link is actually Ethernet extender technology based on symmetrical high-speed digital subscriber line, and it uses a data link standard. Most of you will be knowing this one. Now the device can form a long-haul operational Ethernet network on a single twisted pair cable up to 15 kilometer at data rates up to 14 to 15 megabits per second. Further, the data rate can be doubled up to 27 to 30 megabits per second by using port bonding. And this TDL is used by different armies in different parts of the world. Initial idea of a TDL was introduced by United States of America. Now in many countries, Australia, UK, Pakistan, they are using this one. TDL transmit Ethernet traffic over the copper conductor wire by using line coding technique that I'll explain you. This is actually a mechanism for converting binary 0 and 1 present in data stream into square wave electrical pulses, which can then transmit over a copper conductor wire. Now, when we studied the existing system, that why there was a problem. Problem was of the link. Sometime link was down and received signal strength RSS that was lower than the critical value of the RSS. So that's why the received signal was not translated into the meaningful signal. So after studying previous deployment of armed forces tactical communications during mission critical applications, the drawback was establishment of circuit switch connectivity between the near and far end technical data link units. This problem of resilient long-haul wide medium for tactical armed forces communication network is affected by high bit error rates, whose consequences are low signal to noise ratio levels, which further results in repercussions of transmission and reception of data due to poor line conditions and tentative disconnections. Now, the problem identified in the existing system. After doing many experiments from transmitter up to receiver, we tried to find out the signal strength at different locations. It was revealed that it was problem of unshielded cable in TDL. So it was not supporting end connectivity and giving bit error rate and not giving high SNR. Now, so we formulated our problem after studying existing system that the major operational hurdle faced by TDL system when deployed in field over 15-kilometer hop length was establishment of circuit switch connectivity between the near and far end technical data link units. The connectivity cannot be established due to high bit error rates, whose consequences are low signal to noise ratio levels, which further results in repercussions of transmission and reception of data due to poor line conditions and tentative disconnections. In order to solve this problem, we set certain research objectives. The first thing was to do thorough analysis of resilient long-haul wide medium for tactical armed forces communication network, which are obstructed by connectivity issues to low signal to noise ratio values, which results in high bit error rate. The second research objective was to eliminate a high bit error rate problem, which results in high packet loss and delays. And the third objective that was set to eliminate major drawback of the communication unavailability in TDL network. Alhamdulillah, we achieved all of these three objectives. I'll show you at the end of my presentation. Now, in order to achieve these design objectives, we set certain design requirements that we should be having at the end in a quantified manner, quantitatively. So we wanted to achieve throughput near to 30 megabits per second. This is the maximum limit. If we are having 30 megabits per second, it was acceptable, no problem. Even up to 26 megabits per second, it was okay. So this was our design requirement as a first number. Then we wanted to reduce bit error rate as low as possible, and we wanted to achieve SNR, signal to noise ratio, as high as possible. As you know, nowadays in copper medium, normally noise is not affecting much. Now, proposed solutions. We actually presented three solutions, and they all were accepted, but I'll tell you why we presented three solutions. In this investigation, three deployment scenarios they were proposed. The first one was use of shielded AWG15. It was having diameter of 1.4503 millimeter, and it was having low resistance as compared to the other two. We proposed the second one, use of shielded AWG18, diameter 1.02 millimeter. It was having medium resistance as compared to 1 and 3. The third one was use of copper TT wire AWG20. It was having diameter 0.8 millimeter, it was having high resistance as compared to the first and the second deployment. Now, to adjust the transmission and reception line rates of TDL system units, both on the transmission and reception sides, here we did some firmware configuration settings, which can allow the tactical data link system units to transmit and receive in power line condition with thinner copper conductor diameter wires. When we deployed the first one, it was perfect. But the client, the end user, they told to us no, they wanted to go for a small diameter. Then we went for AWG18, even then they were not agreed. We achieved 29 megabits per second because they were saying that they were working in the field, so they wanted to as thin as possible. So then we went for TT wire AWG20. Now the good thing is that we achieved even over here the 30 Mbps and the low bit error rate, high SNR. Now there's a trade-off, by the way, right? Trade-off is that while going from 1 to 3 deployment, there's a flexibility. If you go from 1 to 3, flexibility of carrying the conductors with you, especially in the field, in mission critical applications. However, there's a more bit error rate and less SNR that we have to set through some intelligent configuration of the firmware that we did. In this scheme, we used a 2B1Q line coding scheme. This scheme was actually chosen to minimize error propagation. And here we used a gray code scheme. Those, mashallah, out of you who know digital logic and design, you might be knowing, that gray code, they're excellent because from one step to another, there's only one bit change. So the inter-symbol interference can be minimized if we use a gray coding scheme. Now the levels, here symbols were defined. Data was coming in the form of 0 and 1. So we made symbols for 2 bits per symbol, 0, 0, 0, 1, 1, 0, 1, 1, and we allotted 4 voltages, -3, -1, +1, and +3. But while allotting these voltages, as I told you, we used a gray code scheme. If you compare these two, the top one is simple 1011 logic, and the lower one is our scheme that we introduced to be 1Q. It is a 1011 001101. Now, this was increasing the data rate as compared to if we use 1-bit symbol. Now, this line coding scheme is used, which is actually 4-level PAM4 scheme, and also refers to as signal modulation technologies. Advantage of this scheme is that by denoting single electrical pulse by 2 binary bit results, maximization of available channel bandwidth. And this is very good as far as bandwidth utilization is concerned. So even if we use for the communication channel, which is having bandwidth of 4 kilohertz, so this is perfect. This is the table just for the depiction. That how we allotted 0, 0 to -3 volts, 0, 1 to -1, 1, 0 to +3, 1, 1 to +1. This is the picture of the system unit that we had used. Now I'll directly go to the parameters that we used. I'll be a little bit fast because this is more technical things. Here we had 4 transmission channels. It was capable of 15 megabits per second at each channel. If we combine 2 channels, this is a port bonding scheme that increased 15 to 30 megabits per second. So 30 for uplink, 30 for downlink, total 60 megabits per second. And TDL can be configured for all modes of operation. We can configure point-to-point, ring, and mesh topologies. Rated voltage was 12 to 48 volts, operating voltage, current 475. We fix all these things, Then these functionalities, they were achieved over there. Port bonding feature that was used, I'll show you in the result. I've used Ethernet extender modules and 4 SSDS modules, 4 LAN, 1 DC, 7 port switch. Tool used is, okay, there are 2 things. One is the classified work done within Pakistan Army. Sorry to say, we cannot declare those results, right? However, parallel to that one, which we were allowed to declare, we can use open source tool for the same. That is the Tamasoft tools. It's a wireless performance parameter. So quickly I'll go to the results, guys, because I have only 1 minute left. Sorry for that. This is the tool output. As you can see, by using this tool, Tamasoft, we disabled the UDP traffic, but we enabled the TCP traffic. And you can see on the top that over here, if cursor can move, but the top, if you see, we are achieving, roughly speaking, about 27 to 29 megabits per second. So, alhamdulillah, the design objective that we met, we initially said 30. We could not achieve 30, but we reached to 27 to 30. And sometime we found a glitch. You see, I just want to tell you, we found a glitch, and this was due to our tool that we were using. And the last thing is about the scenario number 3. 1 minute? 1 minute, okay. For the last, when we reached to the last option, which was the TT wire, it was thin. It was offering more resistance. It was offering us difficulty of more bit error rate as compared to the previous 2 deployments. So what was done over here, that we did some intelligent configuration of the tools. We set with different types of modulation schemes. We set different type of channel conditions. I'm not having time, I'm so sorry for that. But I'm telling you, showing you the result. But even for the 3rd deployment, alhamdulillah, we achieved 14.5 megabits per second. And for the dual channel, we achieved 29. Not 30 again, but 29. It was more than enough for us. So directly to the last slide, concluding. To solve problem of link failure, 3 deployment scenarios they were suggested. They included AWG 15, 18, and TT wire. All scenarios were successfully deployed. Design requirements of throughput, low bit error rate, and high SNR, they were achieved as per design requirements. Thank you very much. Assalamu alaikum.
Many thanks, Abid. And now with the final esteemed speaker, Kenny Louie.
Good afternoon. I'm going to present to you this afternoon. This is a paper that we wrote jointly. We are 3 of us. My name is Mrs. Kenelo Zuva from the University of Botswana, and I wrote with 2 of my colleagues who are in Valley University of Technology in South Africa. So our topic is mobile healthcare benefits and the health threat posed by mobile health technologies in Africa. My presentation is going to cover those areas. The introduction, I'll introduce our paper, and then the literature behind our paper, and then the purpose of our study, because it's a narrative review paper that we did based on data that is available from different sources that will be covered under the methods that we used. And then I'll discuss the results, and then discussions and conclusions. So mobile health actually is a hot topic. The main thing about mobile health is that it uses mobile technology, specifically mobile devices such as laptops, mobile phones, tablets, and so on, which they have to have internet connectivity for them to be useful and to be able to support health and improve health. Then there are services that are delivered over these mobile technology devices, which improves health, which includes the use of SMS, which is short messaging service, social media like Facebook, Twitter, emails, and so on. But our paper is going to specifically concentrate on the use of SMS, which is short messaging services in various countries in Africa. So for the purpose of this paper, since mHealth is a diverse topic which doesn't have any standard meaning, for the purpose of this paper, mHealth will mean any public or private health activities made possible by mobile devices, specifically SMS over mobile phones. So mobile health has actually mobile services, they've got the technology that is advancing and expanding, is actually transforming the healthcare and is key to modern healthcare solutions, according to the research that we did. Mobile devices' portability and ability to operate with minimal infrastructure is regarded as a better option to deliver these health services, especially in developing countries. So this healthcare in developing countries in the African context is actually characterized by limited access to healthcare services, delivery of these services, high costs, low quality, and delay to meet the needs of the clients, which can lead to fatal results, especially if they are suffering from chronic diseases, which comes from unhealthy lifestyles. So this is crippled furthermore by the poverty of the continent, ever-increasing population growth, loaded with high cases of diseases and inadequate health workers. So basically the main detrimental factor again to this is that the healthcare players in these developing countries are separated by vast distances. And then further concerned by poor communication infrastructure, obsolete IT solutions that impede their potential to collect and disseminate information in time. And mHealth has been identified as a viable solution to improve the healthcare, as I've already mentioned, especially when considering that it needs minimal mHealth gadgets, for instance, the SMS. Just the users need to just have a mobile phone. So the statistics that we found was that in 1998, Africa had less than 4 million mobile phones. And then at the end of 2015, about 46% of African population subscribed to mobile devices and is expected to have more than 725 million unique subscribers by the year 2020. So according to African Health Observatory, penetration of mobile phones and associated mobile networks is developing in developing countries such as Africa especially, makes these services to be legitimate and possible, which is good news. So the purpose of our study was to analyze possible hazards. First of all, the benefits that are derived from the use of these mobile phones. This is to be used as mobile health equipment to the environment and the well-being. The method that we use, as I specified already, this is a narrative review paper. So based on the literature that we collected, which we use assisted by this Atlas TI software, which is an existing software that helps researchers to analyze and make comprehensive and objective results about a specific topic. So formal searches were done using the following databases: Elsevier, PubMed, Google Scholar. And then the search was restricted to research articles, date of our publication 2014 to 2017, and publication language English. And then the information that we collected, we used keywords like mobile health, mHealth, benefits, and then within those selected articles, we went further deep into those that address the benefits that are derived out of this use of this mobile technology, specifically SMS. And then we funneled the search results to articles that talk mHealth benefits in African context. Then we continued on doing a second literature search again, which focused on the effects of these mHealth obsolete devices. We used the Gray literature, Google Scholar, and Elsevier databases, and then we used the following keywords mobile health devices and environment friendliness, green mobile health, electronic waste and environment, and e-waste and health. So these are the results that we got from our research. Basically, they are divided into two. It's a brief examination of various benefits that is made possible by this mobile device in mHealth. Extensive review of the potential environmental risks and well-being hazards associated with this discarded or unwanted mobile technology devices. So these are the benefits that we found out from the research that we were doing, that actually mHealth, that mobile technology is bringing transformative power in these healthcare services in Africa, and it enhances communities, both rural and urban, with up-to-date knowledge and information, improved service delivery, reduced reaction time during emergencies. Yet, amid all these benefits, there's also the human error, and then also these mobile devices get lost. And then these smartphones, today the cybersecurity is a hot topic. It also would affect this because smartphones and all these mobile devices used because of this vulnerability to hacking, viruses and malware, especially when these devices are secured through internet connectivity. So here is just a brief results that we got from how this SMS is helping in healthcare in Africa. So in Kenya, my site, I need to get my thing. In Kenya, they use SMS is benefiting to get up-to-date list of health professionals and centers, making possible for the users to locate health services that are near them, which is a plus. And then in Mozambique, the SMS is used to relay much needed information to people with HIV. And then the educational information also help infected people on how to adhere to treatment and prevent mother-to-child transmission of HIV. South Africa SMS is used to provide pregnancy, postnatal, and baby care information to women in their preferred language. The service is actually called Mama SMS. In Rwanda, SMS service called Rapid SMS and Ubuzima is used to track pregnant women and newly born babies and promote early detection of life-threatening emergencies. In Botswana, where I come from, they also use this SMS to deliver, improve actually the patients are willing to receive messages to remind them about appointments and also when to take medications with their mobile phones, because this is also another area that needs to be talked about, because it's not everybody who would want their telephone their telephone numbers to be known and used. So the fact that is for their benefit, so it's a plus in the side of the healthcare system, because that will improve and remind them when to take their medications. So there is also the downside of the use of this mobile technology. So this is another area that we covered, because whilst we looked at the benefits of using mobile devices, then we also looked at the environmental risks and well-being hazards of mobile health devices. So we wanted to find out what are the environmental and well-being threats that are contained by this retired equipment. So literature shows that when this obsolete equipment are not managed properly, they actually become a health and environmental hazard. So the next slide will talk about what is e-waste, electronic waste. So like mHealth, there's no standard definition for e-waste, which is agreed upon like globally. but it comes with different definitions given by literature, or the literature that we found. But for the purpose of this paper, e-waste will be defined as any mobile health equipment wanted by its owner or users regardless of equipment functional state. So what that means is that it could be that the mobile device is still in a working or functional state, but maybe you want to go for a better one. So what do you do with the one that you already have? So the characteristics of this e-waste is that it's a complex problem, and these mobile devices, they are non-decomposable waste, and then there's no single method to properly manage them. So this includes e-waste could be both valuable and also it could be toxic metals. So we extended our research into identifying how can it be valuable, and we found out that these metals include and are not limited to gold, silver, copper, aluminium, and then they can also be toxic like cadmium, mercury, bromine, and lead. So this e-waste toxicity contaminates actually the environment, and then we found out from our papers that it was associated with some cases of liver cancer, lower birth weight, asthma, and other health problems. So management of this e-waste is a big issue, and then it has actually been found that it results in adverse effects on the environment and health. According to Jolanda, he found that there's elevated exposures to e-waste toxic materials from a formal recycling facility. Then you can imagine if there's e-waste from a formal recycling facility, what about the one that is informal? So this also, the toxic elements may leach into soil or water. Okay, they may leach into soil or water and tap into household water sources or contaminate even food chains. So a study conducted in Ghana actually suggested that contaminated water has the potential to kill aquatic life, those living things that live in water. E-waste management in developing countries, particularly Africa, was found out to be environmentally unfriendly, and these findings were disturbing given the dangers of e-waste in the environment and well-being, according to our research. And then the factors of improper management also was because the e-waste regulation is absent, and if it's any, it's actually relaxed. Then there is a legislation issue, which is characterized also by the failure of the international regulation, which is the Basel Convention, which was adopted in 1989, and which runs across the borders. Actually, it controls the trans-border movements of hazardous waste and their disposal. So this is not binding and allows loopholes for illegal waste trade. According to Babatunde also, he urges that illegal trade is motivated by poverty and corruption. So we had 3 points that we were discussing in our paper. Basically, it was the benefits that we get from using mobile phones, specifically SMS, and then also the potential environmental hazards, which is hazardous to human beings and the environment, and then also the management of this electronic waste. So our conclusions were the following: that there is the transformative power of mHealth cannot actually be ignored. Yes, the use of these mobile phones and all these services cannot be ignored. Is actually improving the delivery of health services in Africa. There is more evidence-based work needed on how mHealth advances the healthcare, though, in these developing countries. And then also mHealth has been found instrumental in educating and informing both rural and urban communities in health-related matters. SMS service has been identified as significant, the most commonly used, and is reshaping how healthcare is seen in African context. The downside is the management of obsolete mHealth equipment. In the African region, management of e-waste is inadequate. Though this e-waste can be hazardous, but it's also valuable, which is an open area of research, yet it can still be toxic and harmful. This paper suggests awareness about detrimental effects of e-waste on health and ecology. These are the references that we use. Thank you for your attention.
Thanks, Kiniwili. And many thanks for our esteemed speakers. And it's time for questions.
Thank you. My first question is for Professor Elisabetta Zoanelli. I agree that standards and tools are for evaluation of risk of cyber attacks are fundamental. I agree. If I well understand, you have made a prototype of this system through the POC platforms. My question is the following. How can we ensure that the standards and tools are complete, are effective, and the diagnosis will be good? Is there any test or findings about that field? My second question is for Salim Al-Shanab. You said in your conclusion that the question is how to solve the problem. The three issues that you have mentioned in the conclusion are for sure relationship with financial and network deployment. My question is, if local resources are limited, do you ask for need or help from international organization? And if yes, what is the result of this initiative? Thank you.
Excuse me, is this the last question for Salim or Mahmoud?
About Somalian
Mahmoud.
universities, yeah.
Prof. Mahmoud, okay.
Okay, excuse me.
Yes, you put a very interesting question about standards and tools. As you know, at the international level, whatever the, let's say, the range of sale, both at infrastructures and devices, products, has to do with standards. The idea by the first American research work on this kind of development had to do with the fact that if you impose a standard, then you control a market. So the fact that you can have standards for knowledge representation in this domain, which is a very, very tough domain, is very important. My opinion is, first of all, that whoever works in this context, and that what the literature I presented you is in this direction, has to merge. We cannot have different lines of interpretation of phenomena, and this is one of the critics' points. The second thing is our platform. At present, as I was saying to some friends, saying coffee break, we're trying to do one thing. We propose big companies in Italy working with cybersecurity for the government and so on, to reclassify their corpora of data and see how this reclassification can lead to a decision-making through also what is machine learning. Namely, we have the possibility of predicting attacks and interpreting attacks, making prevention, if we reclassify and interpret data in a relational manner. So this is the solution we have envisaged.
Thank you for your...
Yes, thank you. This research is just finished. And our plan is first to discuss with Somali higher education, communication and technology. After that, we can ask our help to any other organizations. But from the first time, we have to discuss with the higher education ministry. Thank you.
Okay, other question, yeah, please. Hadia, please.
It's not actually a question. My voice is loud, so no problem. Thanks for all the speakers. It was a very good and informative session. It's not a question. It's good news to Elisabetta in regard to ontology. I would like to tell you that Birzeit University on the 25th of September has launched its search engine with 150 multilingual lexicons and a linguistic ontology for Arabic. And this lexicon will be working and helping in the IT applications, and it will help Palestine to move into the fourth circle of the economic revolution.
Thank you.
If you need to reach that, it's on the university website, birzeit.edu, or directly go to ontology.birzeit.edu to know more about it.
This is a very good news, even though I must stress a point. When we talk about control vocabularies in science, we mean with that we must have descriptors at a logical semantic level, which is not only the fact of having glossaries or they are called ontologies. Ontology is something a little bit more complicated. And so in lexical entities, which are only part of an ontology, you must have a number of multiple relations, but also you must have a propositional, contextualized descriptors. And this so far is not excellent. We have tried to do that, and the ontologies I presented to you have this flaw, basic flaw. They are based on the analytics of entities, lexical entities, which is not enough. So it's a good, the one that you said, but this is not enough in order to have an ontology.
No, they finished with semantics, and now the second...
Yeah, but semantics, you see, one of the mistakes, three mistakes. First mistake, there are people that believe that, for instance, ontology web language, which is a metadata language, is this. This is a mistake. We're talking about the second mistake, lexical semantics, which dates back to, say, in the 60s in the States, where the first studies, they're called semantic memory, were started, and the translation into support and electronic support started, are just the basis. Nowadays, if you look at ontologies, they all have more or less the same approach. They give you a definition, then they give you what they call attributes and properties. This is not enough. So what I'm holding is, unless modals become really articulated models, you don't go any further. So these are the problems we face. To conclude, I've shown you a number of approaches. If you look the way they describe relational concepts, you see that they are not tenable at a theoretical level. So what is lacking is the ontological upper level definition. So, the things you said will help, but it's not enough.
No, but it has more. You have to go and visit.
The first application, if you remember, was at Stanford University. They started with a project that was called WordNet. Perhaps some of you are familiar with it, where they identified links according to some sets and a number. But this was a long time ago. We have gone a little bit further. So the point is, at this moment, we need sound ontological, but I will have a look anyway.
Okay, thank you. Is there any question? So I have a question for Prof. Elisa and one for Prof. Salim. My question to Prof. Elisa is that what are the semantic functionalities of ontology used in your tool, and rather than classification? If you mention classification, yeah. I'm talking about as you know, the ontology has many functionalities can be benefited, like reasoning, a lot of functionalities. We'd like to know what are the functionalities you benefit from. Secondly, have you built the ontology from scratch, or you used some existing one and make some integration or something like this. My second question to Prof. Selim, what are the most important applications for the magic square? Thank you.
Your question is a very interesting and complicated question. I'll try to be quick. An ontology is an attempt at describing conceptual entities, and they are based on two conditions. The first one is a definition of the concept, which has to be univocal. That's why everywhere we should use control vocabularies. A control vocabulary, it's a list of items where definitions are univocal, are unambiguous. So that's the first thing. The second thing is to define relations that in an ontology work at different levels. Namely, you have a category, say, of an entity as a category, which is linked at different vertical, horizontal levels, which is not in a taxonomy. A taxonomy is supposed to be a classification, but just to put an example, the very notion of class should distinguish between what we mean, the distinction between an intentional meaning and an extensional meaning. Namely, you have two different approaches to describing properties and attributes of the entity. Second, we must have, in order to understand the function of an entity, you must have what is called a propositional approach. Namely, you have to state things concerning that entity. So as for functional, you hinted at a very important consequence. If you want to make prediction, namely, you have corpora of data, the first question is, whoever sells you big data analytics, a tool, I don't mention tools, what we call just tools, objects. These are fantastic technologies that are no good unless you have an architecture. And the architecture is the ontology. So what they do, for instance, when you do threat intelligence, you go into internet. I say, why do you use a crawler like that? First, let's develop a filter, an architectural filter, then you get data, then you can work on data, and then you can reclassify. So the point where you have got today in cybersecurity is that we have enormous amount of data that are not classified, not even at a taxonomical level. So that's a problem we have. Okay,
there's another part for question. Have you built the ontology from scratch?
No, that was perfect. That is what people who work on this call it a middle-out approach. Namely, you take sources, top-down, bottom-up sources. You collect these sources, try to adapt. For instance, we have used a very important enumeration repository called KPIC. KPIC is an attempt at classification, but it has a fantastic amount of items. We have inserted KPIC, taking out the taxonomical approach, we didn't work in our control vocabulary. So we reuse a number of data sources, otherwise we couldn't work. Yeah.
Thank you.
Okay, well, regarding magic squares, there are sometimes applied statistics and in cryptography, where you can make a very hard-breaking coding. Yeah, it's not easy to decode it if you don't know the right code. So, but I'm not very expert in that field. But I think it's, cryptography is also a secret science. Yeah, usually used by military, so they don't tell people how to they do use it. Yeah, but I think it has some applications there.
Okay. I'd like to thank my speakers again for their very nice presentations. And I have good news for you. This is the last session because the last one was cancelled. So you are free. I'd like to greet our speaker again. Thank you. Many thanks. All right.
Thank you very much, the speakers of the last session. Unfortunately, I could not at least be with you in the last two sessions because we take this opportunity to meet with people, so we have plenty of people's out, meetings outside. So, this is the end of our conference. What I really liked in this conference specifically, the good number of Arab Indian participation. We have 12 countries have been present, but we could not break the number of Oman. Oman was the largest number. There were 14 Arab countries have been present. Now we have 12, but still a good number. So maybe we need to go do it again in Oman sometime with this generous welcome and hosting. So the other thing, I think we have unique and quality of presentation and talks and discussions. In addition to the topics that have been covered, I think they covered most of potential Indian business. Though I know some sessions went to policy and to whatever, but at the end of the day, something that we need to address also. Allow me to thank, I don't know, I hope I will not forget anyone. To start with, thank the speakers. Thank you very much for your contribution to the quality of the text, the topics that you have covered. I would like to thank the steering committee and the program committee for making this program. I would like to thank the organizing team and would like to thank my daughters, actually my colleague Hadia and Yasmin. So thank you very much for your work. I would like also to thank the sponsors. I would like to thank European Commission. You would like to Africa Connect 2 and the Human Connect 3 projects. I would like to thank also Internet 2 SIG for the Middle East. I think the hotel, and we'd like to thank you for your patience and for participation. We look forward. We will not decide where will be our next event. So we have 2 candidates, but we will not announce them. So we will announce hopefully early next year on our next conference. I would like to follow up with all of you on how can we make this for the benefit of our Indians, and we'll have for us the conference is not finished. We will have a meeting with all our partners just immediately after the coffee break to see how we can make use of your advice, of your presentation, and the topics that you have covered. So we will continue work so that we can come up next year in the next conference with something that we can present all together. And I am confident that this good number of participation will give us a push at ASREN to provide better services to our community. Once again, thank you, and see you next year.